All right, gang, Math 1500. The purpose of this video is to introduce you to confidence intervals for proportions. And, if you think about some of the things going on in our society today, there are a lot of issues where proportions play more of a significant role than means. Now, means are always important, like mean ACTs and mean gestation period and, mean salary and different things like that. But sometimes our studies deal with a percentage, and what we have seen so far in previous videos is this represents categorical data because, for example, some things out there right now are the Supreme Court decision about making same-sex marriage equal or same-sex marriage legal, and flying of the Confederate flag on state grounds is one that's getting a lot of attention here lately due to the shooting in Charleston a few weeks ago. But anyway, we get into categorical data. First of all, what if we had a question? What percentage? Guys, keep in mind that percentage and proportion are the same thing. I'm not saying that this is the answer to the problem, but I'm getting ready to pose. But 52% and 0.520, this is a proportion, this is a percentage, same thing. But what if we ask what percentage of adult Americans... Okay, it's early in the morning and I don't have my glasses on. I promise you I can spell, I just can't write. What percentage proportion of adult Americans supports the recent Supreme Court decision to legalize same-sex marriage? I have very strong feelings on this issue. That should be a question mark, shouldn't it? You're not going to know the way I feel. I guess maybe if you were on Facebook with me, and I think some of you are, but you might. I don't even think you'd even know there. I had a student not long ago. In fact, she just completed her PhD in statistics at Ohio State University. I had her in quite a few classes, and she one day came up to me and said, "Dr. Darrow, I just got a question. Are you a Democrat or are you a Republican?" She said, "I've had you in like 5 classes. I still can't tell." Well, the reason is I don't wear my political beliefs on my sleeve. I have strong beliefs about this, but you're not going to know the way I feel. But, I don't think it's my job as a professor to promote my political beliefs. In fact, to be honest with you, politically, I'm actually very independent. I'm strong liberal on some things and strong conservative on others. So anyway, I know y'all don't care about that stuff, but so anyway, what if we did want to address this? Well, our entire population. Sometimes in statistics, we let that be a really large circle. Our entire population would be U.S. Adults. And there's a lot of them. I think we're over 300 million as a whole. I don't know how many would be classified as 18 and over, but let's just say it's around 200 million. Again, I don't know. But we couldn't go out and ask all of the U.S. adults. So what we would do, is we would take a random sample. And let's just go around the country and just randomly select people. Now, geographically, it's important that we don't necessarily, get all people from the Northeast, because people in the Northeast tend to have more liberal beliefs, probably more supportive. Where people maybe in the South and in Texas and other states that are more Republican, we wouldn't want to get all of our people from there because that would skew the results. So we want to try to get a random sample across the United States, and that's really problematic. But in statistics classes, we assume that we get that. So let's say that we could end up getting 1,000 people. All right, and we'd ask them this question, and their answer would either be yes or no, hence the categorical response. Now, what do we know? Well, the central limit theorem tells us some stuff that's really helpful. It tells us that the distribution of sample proportions and we call these our p hats, will be normally distributed with a mean of all the p hats equal to the proportion of the population that has a certain characteristic that we're interested in. And we know that the standard deviation is p times 1 minus p over n. Now, that's all fine and dandy when we're doing probability, because guys, again, back to this drawing that I've given you many times where this is a sample and this is a population. When we're determining probability, this is known and the sample that we get from it is unknown. But guys, in inference, we're reversing that. We go out and get a sample that is known, but what we're looking for in the population is unknown. So what's unknown in this situation? P is unknown. The percentage of adult Americans who supports the Supreme Court decision for same-sex marriage, percentage is unknown. I don't know it. You don't know it. You can go out and look at all the reports that you want to look at. You still don't know it, but you can get an estimate of it. So what we're looking for right here, this mu sub p hat is unknown, but the standard error that we use uses a value that in this problem we assume to be unknown. So guys, what we got to do is we got to come in and make a correction here. We have to use the sample proportion instead of the population proportion. So guys, let's just say that we take 1,000 adult Americans, and let's say that X equal 581, say they support the Supreme Court decision to legalize same-sex marriage. Our p hat is going to be X over N, as we talked about a few videos ago. So this is our estimate. So our p hat here is 0.581, or 58.1% of those sampled say they support Supreme Court decision. Now let me show you what the media does all the time. The media screws this stuff up. They screw it up every single time they report. Well, I'm not going to say every single time, but 99.99999%. What they will do in this situation is they'll come in and say, recent report or survey shows that 58.1% of adult Americans support the Supreme Court decision. This is completely wrong, because this statement right here is making a statement about our population. It is making a statement about the percentage of our population, which, guys, is unknown. It's treating this sample up here of 581 out of 1,000 as gospel wholly the truth, and it's not. It's one of infinitely many samples. If we had taken a sample of 1,000 adult Americans 2 seconds later, we would most likely get a different count. We would get something different than 581. We may get 682. We may get 482. Samples vary, as we saw back in the distribution of sample proportions when we're studying the central limit theorem. These things vary, and they vary according to the standard error. There's nothing holy about this 58.1%. This is one sample of infinitely many of size 1,000 that we could have collected. But this is our estimate. This is our estimate for P, the percentage of adult Americans, all adult Americans who support this decision. But because it's not perfect, because it has room for error, margin for error, we're going to do that. We're going to build margin of error around this estimate and create a confidence interval. Well, what we saw before is when we had a sample mean where the population standard deviation was given, we saw that we could use this formula. Well, this doesn't apply because we don't have a mean. We got a percentage, a proportion. We saw that when we're trying to estimate an unknown mu, where the population standard deviation is not given, then we use these. Both of these estimate mu. Well, what should we do when we estimate P? We should use what we've created here to create a new formula. Now let's think it through, guys. X bar estimates the unknown mu. What's going to estimate the unknown P? P hat. So we're going to put P hat right here. What distribution? Is it the Z distribution or the T distribution? You're not supposed to know the answer to that one. That's my job to teach you that. But guys, the Z distribution models this phenomena. What does the standard error look like? Well, before it looked like this, didn't it? But guys, we know now we're working with the assumption that this P is unknown. We're trying to estimate it. We don't know the percentage of adult Americans who support the Supreme Court decision. We're trying to use our sample to estimate this value that's unknown. So guys, we don't have P, so we have to replace it with the next best thing, the estimate for P. Sorry gang, I need some coffee. So let's take this confidence interval formula. Our sample showed 581 out of 1,000, which is 0.581. So what's our sample? I'm sorry. Let's do a 95% confidence interval for P. So what does this give us? Again, P hat plus or minus C star square root P hat times 1 minus P hat over N. Guys, plug and chug. That's all it is. And I'm even going to show you how to do this on your calculator even easier. P hat's 0.581. You can look back in your notes. The Z critical for the 95% confidence interval is 1.96. P hat 0.581. 1 minus P hat. I see that that's 0.419, but let's say you don't see that. Let's say that you've got other talents and mental arithmetic isn't yours. Okay, just do this. Let me see if I make that a little bit clearer. Maybe, I don't know. So 0.419. Use your calculator, it's not a big deal. And our sample size in, well, we took 1,000 people. We know there's nothing holy about these 1,000 people. This is one sample of infinitely many. We're going to use it as our best estimate, but we're going to build margin of error around it so we can get an estimate within a specified level of probability or confidence. Well, the first thing I'm going to do is just do the negative of it. So 0.581 minus 1.96 square root. So I got 0.581 times 0.419 divided by 1,000. Guys, don't stop that underneath the radical sign, the square root sign, until you get the 1,000. I'm going to hit the right arrow. That's the way this works. And I'm going to hit enter. Now I'm going to go second function, enter, because the only thing that I need to change, I may be able to go right and start over. Nah. So I got everything typed in. If I typed it in very carefully the first time, it's kind of cool because all I have to do is change one thing, change a negative to a plus. So getting my 95% confidence interval will be 0.550 and the right is going to be 0.611. Now guys, this 5 right here is going to change that 1 to a 2, so 0.612. Now sometimes it's kind of weird to talk about things in proportions. It would probably be more appropriate here to put this in terms of percentages. So we would say that based on this, guys, I just made this in. Well, I didn't really make this up. I looked at some studies, and I've created some numbers that were similar. So we would say that there's a 0.95 probability, or with 95% confidence, this interval contains P, which is the percentage of adult Americans who support the recent Supreme Court decision. Now again, don't run out and tell your friends, you know, Dr. Darbush told us that a lot of people support. I made this stuff up. I actually got a handout that I'll probably do in the next video that will actually take some data that I actually got from a CNN report, and we'll show what they do wrong, but we'll do it the right way. Okay. Now, one thing that we can do here is we can calculate the margin of error, and that's always something that that we want to do with the confidence interval. And guys, remember, the easiest way to do a margin of error is to do the big number minus the big number minus the small number. Easy for you to say. All right, so put that in our calculator. And our margin of error is plus or minus 3.1%. So that tells you with a 0.95 probability, we feel pretty confident. 95%. Some people give statistics a bad name because they're like, well, you're only 95% confident. And, well, 95% is pretty good. If you can find a game in Las Vegas that pays you 95% of the time, you will win 95% of the time. Sell the house, the car, the dog, the wife, the husband, whatever, and get to Las Vegas quickly because you can be the richest person in the world. If you go there with $1,000, you can be the richest person in the world in a couple of months. All right, gang. Let's. Not really sure where I want to go from here. Let's use this result. And let's say we feel pretty confident that our p hat, which is 0.581, was a decent estimate. I always drive my dad crazy. He takes these polls. He takes them just so literally. I mean, he thinks that they're just the gospel holy. And I'm sitting there thinking, it's one sample. It wasn't random. It was a phone interview. It's yada, yada, yada. I can think of all these problems with these samples, why that we shouldn't really pay much attention to them. And I'm going to show something out like that. Show something like that here in just a second to you. But let's say that we feel pretty confident. We did a good job of collecting our 1,000 people. We did it randomly. We did a random sample. We feel this is a decent estimate, and we'd like to conduct a new study. Sort of based on this result. But we would like our margin of error to be much smaller. We would like our margin of error to be 1%. What sample size N should we collect? Well, let's go through this. This is something I'm going to go through in detail so we can create a formula where we can use this in situations in the future. All right, so we know that the margin of error on any confidence interval formula is the plus or minus part that starts with the critical value times the standard error. And I've given you that before, okay? We want our margin of error to be 1%, but we know that we can't use the 1% in mathematics. Any sort of calculations of percentages, we have to use the decimal. We don't need the plus or minus because that's just going to confuse the calculations. We know that'll be given in the end. We know our p hat is 0.581, and we saw earlier that subtracted from 1 was 0.419. And we'd like to know the sample size. Guys, sorry, my voices. I know that comes across through the... kind of comes across gross through the thing, but anyway. So... all right, take my headphones off. All right, so the first thing I'd want to do is divide by 1.96. So on the left-hand side, I'm going to keep all this running. I know students hate that, but I want to keep this at 0.01 divided by 1.96. And of course, you know, these things are, as you guys like to say, cancel. So we got that. I think it's reasonable. Next thing we do, we'd want to square both sides. Students ask me sometimes, why'd you use parentheses over here? Why'd you use bracket over there? I don't know. I just did. on the right-hand side, I just give 0.581 times 0.419 over n. Now, if you think about it, this right here is over 1. So I can take this complex fraction, I can take this and switch it. So I can bring the n up here. All right, I can bring the n up here. And then over here, I've got the following. I've got the 0.581 in the numerator, and times 0.419, but I've got this entire quantity that comes to the denominator. Now, you're probably thinking, well, that's not the way I'm going to do it. Guys, trust me, do it this way, because we're going to learn something from this. So the first thing I want to do is I want to take care of this denominator. I like to do this in parts. So if I do 0.01 divided by 1.96 quantity squared, I get what's in the denominator, right? I get, in my calculator now, I have this stuff right here. So I want to take 0.581 times 0.419 divided by the answer. Guys, this answer key is right here. ANS. That tells me anytime I can take the answer from the previous line and bring it into the next line. So I don't lose any estimating power here. I use the entire decimal. This -5 says I need to move the decimal place 5 places to the left. This takes the entire answer. I'll get a decimal, always round up. So guys, I need 9352 as my sample size. I need a really, really large sample size to get the margin of error within 1% of the true value at a 0.95 probability or with 95% confidence. Okay. Now, there's a reason that I wanted to write everything out like this. For our next problem like this, is there anything that we can do? Can we learn from all of our work up here to make it easier? Yeah. What is the significance of the 0.581 in this problem? That was our p hat. What's the significance of the 0.419? That was our 1 minus p hat. The stuff in the denominator. We got 2 of them, right? What was the significance of the 0.01? Well, guys, that was the desired margin of error that we wanted. And what was the 1.96? That was our z critical. So, guys, the next time you encounter a problem like this, and, students all the time are like, well, Dr. Darber, I don't understand how to do that. Guys, all you got to do is plug and chug. Let's say you go out and take a sample and you find out that your p-hat's 0.32 and your desired margin of error is plus or minus 2%, and you're doing a 90% confidence interval. Plug and chug. 0.32. 1 minus 0.32. Margin of error. Z critical. Plug it in your calculator, round up, and you got your problem. You got your solution. Now I want to show y'all something. I want to show you a study, and these things are all over the media screws this stuff up like crazy. But I just want to show you all. I don't have Google Chrome going. Let's get my wife's Facebook page down. Hopefully there wasn't anything. Everybody's going to be freezing their screen to see. Hopefully there wasn't anything politically charging there. All right, gang. Let me get out of this crazy thing. Okay. Get rid of that, and let me bring up Google Chrome. All right, now I want to go to Rasmussen report. they do a daily presidential tracking poll that you hear this poll referred to quite a bit. Let me put my glasses on so I can read this along with you. And I want to show you. I mean, these people are pretty highly respected, not by me. Let's get Serena and Venus off the. All right, so it says right here that what they do. Um, they report every day what's something called a presidential tracking poll, and let me make this bigger so I can talk about some things. Okay, so the Rasmussen Report Daily Presidential Tracking Poll for Monday. So this is for Monday, July the 6th. So I just came in and pulled this one out because I'm not putting this up on Monday. Shows that 48% of likely U.S. voters approve of President Obama's job performance. This is a lie. And I don't think that there's any intended deception here because this statement right here speaks for what? The population of likely U.S. voters. They did not go out and poll every single likely U.S. voter. In fact, what they did is they did what's called a rolling average. They take a 3-day rolling average. They will phone, I think, 500 people today, 500 yesterday, and 500 the day before. And they'll do a rolling poll on the 1,500 people over the last 3 days. Now, we'll go down and see, actually, they may have changed that, but that's the way they used to do this. 48% of likely U.S. voters is a lie. That's not what they found out. They found out that 48% of the 1,500 that they sampled approve of the President Obama's job performance. Now, guys, one thing I'm going to tell you, I'm not here to bash Obama. I'm not here to make him out the greatest thing ever. That's not what this is about. This is about statistics. This is about me reporting statistics and how statistics are collected and how they're reported. I did this same thing when Bush was president. I did this same thing when Clinton was president. And I'll show you some if I've been teaching back in Reagan days, I would have used it then if it was even there. So let's go on down and see what we can find about this. I'll show you one report that I kind of find interesting. The approval index. Let's see, is that the one I like? Let me see if I can get this. Yeah, the approval index. Red means people don't approve, and green means people do approve. And I always find this kind of interesting that the day he took office on 5 years ago on January 20th, that there were actually people that didn't approve of him. I think that's kind of funny because he hadn't done anything yet. He hadn't even gotten office yet. This was the day that he was inaugurated. There were people who didn't approve. But there were people who did approve, and that to me that's just as crazy because if somebody called me on this day and said, "Do you approve of the job that Obama is doing as president?" I'm like, "Well, let's let him be president first and let him do something, and I'll tell you whether or not I approve." But it just shows you how people are so politically tied, or so tied to their political parties that they can talk about the job a person is doing. And same thing with Bush. They had this with Bush too. Democrats didn't like him, Republicans did. Same thing there. It's weird to me that we can approve of a president or disapprove either one before he even does anything. You'll notice that Obama's red, so their approval index is more people that disapprove of the job than approve. This was the same thing with Clinton, same thing with Bush. So we really, in this country, we just don't really like politicians much. All right. And again, I have strong feelings about the job that Obama is doing, but I'm not going to share them in this platform. So here's the good stuff right here. This actually gets down to some decent stuff. So it says daily tracking results are collected via telephone surveys. Guys, right there, you know what that tells you per night? You can pretty much forget this stuff. Uh, today with call block and caller ID, and I get reports from or calls from these people sometimes, not necessarily Rasmussen, but there's many times I don't even take the phone call. Um, but anyway, they've sampled 500 people and reported on a 3-day rolling average basis, as I talked about before. To reach those who have abandoned traditional landline, uses an online survey tool to interview randomly selected participants from a demographically diverse panel. Well, that's better than just the way they used to do it with telephone surveys, but it's still not good enough to put much meat and potatoes, as my grandmother would say, into this. But anyway, they do come in and actually kind of correct the ignorant statement they made earlier. Now, they say the margin of sampling error for the full sample of 1,500 likely voters is 2.5 percentage points with a 95% level of confidence. So, this ridiculously dumb statement they made back here that the Rasmussen daily presidential tracking poll for Monday shows that 48% of likely U.S. voters approve. It doesn't show that. The Rasmussen Report Daily Presidential Tracking Poll for Monday shows that 48% of the 1,500 people who were sampled. Was this a good sample? Is it generalizable? I don't know. I'd say probably not. So, guys, I don't. This is a report that is people put a lot of stock in, and people put confidence in, and I think it's gibberish. I don't pay much attention to it at all. I don't pay much attention to polls, period, but other than just for entertainment purposes. But sometimes they get it right. You'll find 1 out of a million polls. Well, maybe not that bad, but you're not going to find many that get it right. Gang, that's all I got. Next video, we'll work through some problems on these confidence intervals per proportion. So take care.